2 years ago, I published a primer and shared it here at the summit. And since then, I've been obsessively reading the headlines about machine learning. And in general, you'll get two broad categories of articles on the front page. And headline one is "The robots are coming for your jobs," which is we are headed towards some kind of mass unemployment event. And then once we're all unemployed, we lead to headline number two, which is on the front page. Headline number two is "Skynet is coming for your children." In other words, AI is going to get smarter than humans at everything, and we're going to be the also-ran species on planet Earth. But a funny thing happens if you flip to the back pages of the same newspapers, or if you read different journals, like I do. So if you're geeking out with the nerds, you will see a very different set of headlines, and these are the stories that I want to share this morning. Machine learning is a fundamental set of computer science techniques that we're now busy putting into all of the software that we write. And if we do it intelligently, if we do it thoughtfully, if we do it compassionately, it will make us better decision makers, it will help us live longer, and we're going to be better together. So this is the counter narrative that I want to inject into your brains. The robots aren't coming for your jobs. Skynet's not coming for your children. Machine learning is actually going to make us better humans. So before I get into the details, let me share a little bit about what's going on in the broader machine learning community. So the biggest AI conference of the year is called NIPS. This year, it sold out in 11 minutes and 38 seconds. Now, it's not quite a Beyoncé concert yet, because she can sell out in 22 seconds. But for something called the Neural Information Processing System Conference, I would say 12 minutes is pretty good. So the academics are fired up. This is my friend Paul Doherty, who is now the CTO of Accenture. In 3 decades at Accenture, he's seen a lot of technology trends. He's seen the rise of client-server computing. He's seen the rise of the internet. He's seen the rise of smartphones. And he says he has seen nothing grow as fast in businesses as AI. So the businesses are busy deploying. So you got the researchers fired up, you got businesses deploying, the politicians won't be far behind. And in fact, politician after politician in their country or their region have planted the flag and said, look, my country, my region is going to be the best place to build an AI company, the best place to do AI research. They're pouring billions of dollars of spending into encouraging the ecosystem, and no country takes this more seriously than China. China has a national top-down goal to be the #1 country in AI by the year 2030. And to give you a sense of how seriously they're taking it, may I present the Chinese government's infographic. 5-year milestones boiled down so all of the citizens can understand it. This is how we're going to be the world leader in AI. So we have all this energy. We've got the academic energy, we've got business deploying, we've got politicians saying, look, I want to be the best place to do AI. So now it's up to us to harness this energy and build thoughtful applications that really can help us be better. And what I want to do is take you on a tour of what that looks like. A tour of categories of software that will make us better humans. So this is going to be one of those tours that's kind of like package tours. So day 1, we're going to be in Tokyo. Day 2, we're going to be in Shanghai. Day 3, we're going to be in Hong Kong. And so apologies in advance for people who like the vacations where you just wake up and you're on the beach all morning. This is not that kind of presentation. We're going to see a lot of examples, and I already had heartbreak over the cities I had to lead out of this presentation. So let's get going on the tour. So first category of things I want to talk about is that if machine learning can automate the mundane and routine things in our world, then we can lean into uniquely human strengths. So to set the stage, let me sort of introduce a quote from one of the most prolific and creative humans of all time, William Shakespeare. So he has Hamlet say, "What a piece of work is man, how noble in reason, how infinite in faculties, in form and moving, how express and admirable, in action, how like an angel, in apprehension, how like a god." And so he's saying, look, humans can be logical, that's fantastic, noble in reason, but they are also infinite in faculties. They can figure stuff out. They can think outside of the box. They can be creative. They can be empathic. And it's these qualities that are very, very hard to automate with machine learning. Understanding other people, thinking outside of the box, creating, connecting dots. These are all uniquely human strengths for now. Machines have a hard time doing this. So if we could get the machines to automate the routine, we can lead into these things that machines can't do. Let's go on the tour. So it turns out you and I are addicted to Amazon Prime, apparently, and increasingly addicted to the same-day delivery service. And to do this, Amazon's had to build distribution centers closer and closer to their house. And they've populated these distribution centers with hundreds of thousands of robots. They bought a company called Kiva, and they are literally over the 100,000 robot mark. What these robots do is they carry the yellow bins throughout the distribution center, something that humans used to do, a repetitive task. Now, you might think that they've reduced the number of humans in the distribution center, but nothing could be further from the truth. They've hired 235,000 people. Just think about that for a second. 235,000 people in the last year are new Amazon employees. Most of them work in the distribution center. And they're doing new types of jobs because they're not carrying the bins anymore. They're actually getting the robots in a position where they can carry the bins. And they're unsticking the robots when they get stuck. Because humans are great at thinking outside of the box. What is wrong with this situation? Why is the robot not capable of doing what it's programmed to do? They can get the robot unstuck. This is exactly the kind of work that I'm talking about. Humans can do the creative work, machines can do the routine work. Here's another example. Most of you work in an organization where you have lots of customers and partners, and you have a customer relationship management system. Well, actually, most of you who work in organizations have like 20 CRMs. But there's a common trait across all 20 of your CRMs, which is most of them are empty. Why? Because it's a pain in the ass to put stuff into your CRM. So what if there was a system that could automatically populate your CRM? It could look through your emails, your phone records, your calendar entries, figure out who you're talking to, and then automatically create the entries in the CRM. Then we would get the insight that we would want out of CRMs. For instance, you could have every rep on a call get a reminder on a timely basis, like it's Friday afternoon at 3, it's time to call Katie, your prospect at Acme Corporation. Because we know that Katie is most receptive to calls at Friday at 3 as opposed to emails on Monday. That's the insight that you want out of your CRM. If we had the system automatically populated, then the insight would actually come out. Here's another example, which is lawyers preparing for trials. So the first step of any trial prep is to gather the evidence. So mountains of paper show up, mountains of logs, lots of depositions need to be transcribed. Everlaw is a portfolio company ours that transcribes those calls, gets all the documents, and then does the routine work of sorting them, categorizing them. Is this document relevant for this trial or not? What is this document about? Is it about fraud? Is it about anti-money laundering? Is it about know your customer? What is it about? And once we have all the documents tagged, then the lawyers working the case can work on the creative task of how do I connect these pieces of evidence? How do I tell a story that resonates with the jury? You see, routine work done by machines frees the humans to do the creative work that only they can do. Here's another example. We have a company called Dialpad. They offer an internet telephone service, and it's got a web conferencing feature. The web conferences can be recorded, and then we can transcribe the audio. And if we transcribe the audio, then we can get insight out of these calls. So for instance, after we transcribe the audios, we can read the text, and we can do sentiment analysis on that text in real time. Let me show you what that would look like in a system. So you see this call is being monitored, it's neutral, it's just gone negative. The sentiment on this call in real time, something's wrong with this call. And what we can now do is give the people on the call real-time advice about how to repair this conversation. That's the type of insight that can come when we can automate the routine things like transcribing calls to drive insight, like something's going wrong on this call. Imagine you could do that exact same thing in the doctor's office. So I actually just happened to see my primary care physician 2 weeks ago. He spent about 35 minutes with me, and 25 of those minutes, I timed it, he was typing into his computer because he wanted to keep my electronic health record up to date. Now imagine that there was a system that could actually listen to the conversation that we were having, and it would automatically transcribe the call and get the right things into the customer record. What that would mean is that he could pay more attention to me. He could communicate more. He could ask another question. about how I'm doing. And I think as we introduce machine learning into the doctor's office, two things will happen. One, most doctors will get very good at diagnosis because we're going to use machine learning algorithms to figure out what's wrong with you. And then most doctors will have up-to-date patient records with systems like Suki. And so the reason that we'll choose a doctor will be the one with the bedside manner, the one that can relate to us best, that hard-to-do human thing of empathizing and connecting. And that's exactly what we want from our doctors. All right, one more example of automating the routine. This is my personal favorite because in my family, I am the designated photographer and videographer. And in general, my kids are pretty well behaved, but I can always get them to roll their eyes at me when I ask them to pose for a picture. Because I'm pulling them out of the moment. I'm making them stand. I'm making them smile, right? It pulls them out of the moment. So what if there was a system, like a drone, that could automate videography? In other words, it would position the camera exactly where it needed to be. It would start and stop the camera at exactly the right moments. It would pan and zoom to get to the best place. That would allow me, the photographer, to just rejoin the moment, to be in the motion of the moment. And here's what that footage could look like. Completely automated footage from a drone. Automating the routine so we can stay in the moment. All right, second category of things. We're in a new city now. I want to talk about giving ourselves superpowers in the physical world. So our perceptual systems are fantastic. You can see a ton of colors. The resolution that your eyes can break down is astounding. But there's also well-known limitations to our perceptual systems. This is why we have bomb-sniffing dogs and not bomb-sniffing humans. You also tend not to remember what you saw or heard that accurately. So what if we could design around those limitations of the perceptual system and give ourselves superpowers in the real world? Our portfolio company, Pindrop, does exactly that. It gives the powers of banks and retailers and government organizations the power of super hearing. So when would you use super hearing? Well, when you're on a phone call with somebody. It turns out that when you interact with an organization, 78% of those interactions still occur over voice, which is pretty surprising in the era of text and websites. 80%, almost 80% of all interactions with an entity are over voice. Because of that, the bad guys have figured this out, and they're calling call centers trying to impersonate you so they can transfer money to their accounts, so they can order a dozen iPhones and just go pick them up and sell them. In fact, 90 voice fraud attacks happen every minute in the United States. What can we do? Well, with the power of super hearing, what we can do is listen to the call and figure out if it's really you. Establish a voice print. And this is harder than it looks like because your voice changes over time. So as you age, your muscles loosen, and that changes the frequency of your voice. And so we need to keep up with your voice over time. The other thing that we can do is we can listen to the noise on the call, which is what Pindrop does. It turns out every phone that you use generates a unique noise signature. So your iPhone from home sounds different than a Skype call from Estonia. And because of that, we can pinpoint where you're coming from and help combat fraud. Super hearing combats voice fraud. Here's another example of superpower. As the population of the world grows, we need a more efficient way to grow food. Most of the world's population lives in cities. So it'd be fantastic if we could locate the farms close to the cities. Food is fresher, less fossil fuels burned in the transport of that food. And so there's a whole set of startups building indoor farms. So they're lit by LEDs and they're populated with robots. Part of the robot's job is to watch the plants grow. So you remember how I said one of the limitations of our perceptual system is we have a hard time sort of seeing a sequence of data and noticing subtle differences. We can build machine learning systems that compensate for that. So these machine learning systems watch the plants grow. They know exactly what a head of lettuce should look like on day 7, and day 14, and day 21, and day 28, and that lettuce isn't thriving, we can vary the environment. We can change the temperature, the water, the nutrient mix, the humidity, and get that head of lettuce right back on track. The yields coming out of these indoor farms is astounding. One of the metrics that we use is to figure out how many pounds per square foot of growing space. So how many pounds of lettuce can I grow? These farms are generating 15 pounds of lettuce for every single square foot of growing space. Compare that to 7 pounds in a greenhouse, which is already a controlled environment, and 1 pound in an open field. So 15x the yield from the same space, and all the while we're doing it with 95% less water and no pesticides. The power of super seeing makes us better farmers. Here's another example. So we have a portfolio company called Drishti, and what they do is they help people in factories. Despite our massive investment in robotics technology worldwide, something like 90% of all factory work is still done by human hands. Now, the challenge is that there's a lot of turnover in factories. It's hard to keep workers on these jobs. An extremely well-run factory in the United States might have 30% turnover a year, which means that every 3 years or so, you're looking at a completely new workforce. In China, it's not unusual to have 2% turnover a day, which means that in a small number of weeks, you have a completely new workforce. And so onboarding these workers is critically important. Drishti watches workers as they work, and they can decompose the video of them doing their work. I'm going to run the video here, and break it into pieces. Now this worker is installing the switch. Now he's testing the switch. Now he's closing up the case. So if we can watch what people are doing, and we know exactly what tasks they're performing, we can give them real-time advice about, here's what you can do now to help them learn their job faster. Customers that have deployed Drishti are experiencing 25% increases in labor productivity, and error rates are going down by half. In other words, the number of mistakes the workers are making falls in half. Here's another area where super seeing would be helpful, and that's in construction. So if you're building a hospital or a distribution center, you'd love to have a daily progress report of how you're doing. So you have the blueprints, that's what's supposed to get built. And then with technology from a company called Doxel, our portfolio company, you can actually get real-time daily updates, and here's how it works. Doxel sends these robots after the workers leave at the end of every day. The robots generate a 3D accurate view of what just got built. What they can do is break down all of the components. Here's the pipes, here's the ductwork, here's the electrical. They can give you a real-time status report of how far along in the construction project you are for each one of those components, and basically figure out how much more is left to do. In other words, what workers will I need on site tomorrow? Customers like Kaiser Permanente that are using this technology are finding almost incredible 38% increases in labor productivity. And they recently finished one of their buildings in San Diego, 11% under budget, by noticing things like, the electrical work I just put in is not quite in the right place. Super seeing makes us better builders. Here's another example, and I shared this last year when I talked about self-driving cars. One of the second-order effects of self-driving cars getting everywhere is that we're going to have sensors in lots of places. Everywhere a car goes, there's going to be a dozen cameras, 2 LiDARs, lots of radars, and so we have a perfect picture of what the car sees. Think about that, what that means for the legal system, is we have perfectly reliable witnesses everywhere a self-driving car goes. So let me give you sort of an example of this. So it turns out Tesla just turned on this feature in their cars where the drivers can now get access to the video that their Tesla's cameras are seeing. The Teslas have always had cameras because that's how the algorithms do the auto drive feature. But now users can actually, take the videos and upload them on YouTube. So this video is from a Tesla user from 3 weeks ago. It's a driver in North Carolina. And before I play the video, let me just say that nobody actually got hurt in this accident, but there was definitely a he said versus she said confrontation that happened where both drivers insisted that they were not at fault. So let me roll the video from the Tesla dash cam. And you will see in a matter of moments a white Honda Accord pull out into the middle of an intersection and essentially stop. Okay, so the Accord is clearly at fault here. They pulled into the middle of an intersection and stopped, but there were no witnesses around, right? And so imagine how you would actually process this insurance claim or determine fault. There is really no way to do it, but the power of a super reliable memory attached to a sensory system that's everywhere will resolve this case instantly. We'll know who's at fault. All right, one more example of super seeing in the real world, and this is for people whose perceptual systems are actually damaged in some way. And in particular, we're going to look at people who have vision impairments. There's a fabulous company in Israel called Orcam, and look at this product that they make. It clips on to your glasses, and we'll let the video tell you what it does.
A large rose tree stood near the entrance of the garden. The roses growing on it were white, but there were 3 gardeners. Face recognition.
I don't have vision impairment, but I need that feature. I'm always forgetting your name, so apologies in advance
Money
later.
notes detection. $50.
So this clip onto your glasses will help people with vision impairments lead much more normal lives. Super seeing in the real world for them. All right, we're on to our next city. This category of software, I'm going to share examples of how machine learning can help us make better decisions. Now, it's certainly true that we can program machine learning systems to not do that. You can actually systemize existing biases. So, for example, if you work in an organization that systematically promotes men ahead of women, and then you train a machine learning model on what to look for, you're going to have a machine learning system that systematically promotes men ahead of women, right? So if you don't want that, you need to find and serve the right data into your data set. And you need to deploy systems that actually compensate for problems in our decision-making, like the one I just mentioned. And let me show you examples of that. So the first example is a company called Textio. The company was started by a set of Microsoft Office people who worked on Microsoft Office. And what they're writing is a real-time guidance system for writing things like job descriptions. So as you're writing your job description, it'll literally watch what you're writing, and it will try to optimize your writings to be most attractive to candidates who can do that job. One of the tools that they give you is the gender meter. You see that right above the laptop there, and it will say, as you're writing in real time, you've written words that are more appealing to men than to women. You might want to correct that. The other thing it can do is address for regional differences. So for instance, if you put the phrase, a great work ethic, into your job description, and everybody's seen that phrase in a job description, that plays great if you're hiring workers in San Jose. But it actually is negative for workers in Everett, Washington. So if your candidate pool is coming from Everett, you want to pull that phrase from your job description. Machine learning will help us overcome limitations we didn't even know we had in our decision-making process. It'll help us make better hires through better job descriptions. Here's another example. So in most organizations, the Pareto effect is widespread across all teams and all functions. So 20% of your reps generate 80% of the revenue. 20% of your software engineers generate 80% of the useful software for your team. So what if there was a system that could watch what these 20% were doing, automatically extract best practices, and then give real-time coaching to the people who weren't in the top 20%? That's exactly what Cresta.ai does. They're starting with sales and marketing professionals, so think people who are chatting with you right before you make a purchase. Customers like Intuit who've deployed the system found that they get as much as a 20% increase in conversion rate on those chat sessions, on 66% less training time. You train your reps less, and they're closing more deals because they're getting the real-time guidance from Cresta, which has figured out what are the top reps doing, and automatically giving real-time guidance to the reps who aren't performing at that level, right? We become better salespeople through machine learning. Here's another example. So those of you that were here last year saw me present on self-driving cars. One of the big transitions we're going through is from gas-powered cars to battery-powered cars. It turns out, with today's battery chemistry, one of the minerals that we desperately need is cobalt. Cobalt helps make batteries last longer and go farther. The bad news is that 50% of the world's known cobalt reserves are in the Democratic Republic of Congo. And when organizations like UNICEF and Amnesty International have sent people on the ground to look at cobalt mining operations, they found as many as 40,000 children working the mines. No safety protocols, no safety equipment. So if we had a reliable political partner in the DRC, we'd obviously go try to attack that problem, but we don't have a reliable political partner there. So what we need to find cobalt in other places. So the traditional approach to this would be you'd hire a bunch of geologists. They would generate an educated guess list of where the cobalt would be. Better, we can use technology. There's a company called Cobalt Metals, which absorbs multiple data streams, things like what's the weather like, what plants grow, what are the rock formations like, what types of rocks are there, what are the wind and wave patterns. And they can absorb all of these pieces of data and then generate the likelihood that you're going to have a big concentration of whatever mineral you're looking for. So we can make the geologists even smarter. So before we go to the big expense of hiring an expedition team, getting all the heavy mining equipment to go dig up the earth to see if there's cobalt, we're going to have a very high probability assessment before we go to that expense. Better mining through machine learning. We can also make better loans. And in particular, we can make loans to people who have never gotten them before. Our portfolio company Branch makes tiny loans, think $1, $2, to first-time borrowers in countries like Kenya, Tanzania, and Nigeria. They just launched in Mexico. And in these countries, the credit bureaus either don't exist or they don't reach everybody in the population, and so there's whole swaths of people who can never get a loan, never gotten a loan before. Branch has stepped into this opportunity, and what they do is they ask applicants to download an app, and we can start watching their behavior. So if there's no credit bureau ranking of have you repaid loans in the past, what we can just do is look at your behavior. And here's what they found in a couple years of making loans. Here are behaviors that make you more likely to repay a loan. So first, you use a brand name phone like a Samsung or HTC. Okay, that makes sense. You use your battery sparingly. In other words, you don't burn through your battery all in the morning. Interesting. You take most of your calls in the evening. You receive more text messages than you send. You have a more active Facebook profile. In other words, you're posting more from more different places. And then maybe counterintuitively, you have other gambling apps on your phone. So being a gambler or using gambling apps actually makes you more likely to repay a loan, which might be counterintuitive. But that's exactly the point, which is if you asked a human decision maker to say, please describe the person most likely to repay a loan, you're going to get all kinds of human biases and personal experience wrapped up in that recommendation. What we want is we want the algorithms to tell us. The algorithms will tell us who's likely to repay a loan. All right, one more example on human decision making. What you're looking at here is a slice of tissue. This is currently the way we diagnose whether you have cancer. It's called a tissue biopsy. We'll cut a piece out of you, we'll freeze it, we'll slice it into thin slices, and we'll dye it, and then we'll put it in front of a trained human radiologist, and their job is to look at that slide and say cancer or no cancer. We've been starting to introduce vision processing techniques into these environments, and what you can do is use the exact same techniques we're using to recognize whether grandma's in your photo, to look at these cells and highlight the regions where there might be cancer. So this is a heat map generated by an algorithm that says, in the red areas, I suspect there is cancer. So now we can do an experiment. The experiment is this: who finds the most cancer? And we'll have 3 teams compete. Team 1 is the algorithms. This is a study done at Harvard and Cornell last year. And in that study, the algorithms find 92% of the cancer. Then we show them to the human pathologists who find 96% of the cancer. Go team human. But the fascinating thing is if we let the humans use the algorithms, together they find almost all the cancer. So here's what's happening. It's kind of like using the spell or grammar checker in your browser when you're writing a message. Sometimes you're just writing along and you'll typo something and it'll find it for you, right? You might have missed that typo. And then sometimes it'll red squiggly line the whole thing and you're like, no, that's right as written. I meant it that way. It's this push and pull, this dialectic, this, hey, had you considered this? that together make you a better writer in your browser, and it turns out it's making the pathologists better cancer finders. We're literally better together. All right, city 4, automating dangerous jobs and tasks. I'm gonna show you a bunch of very cool drones and other technology. The first drone I wanna see you is called the Little Ripper, and it was involved in what we believe is the first ever ocean rescue by drone. So it turns out this drone has a camera on it and it can detect sharks. And so it was on a mission to detect sharks when a distress call came in from 2 surfers who were being pulled away by very dangerous surf. Let's watch the video. What the drone is gonna do is find these people who are being pulled away by the surf. This is about 77 seconds after the distress call went in. You'll see 2 people, eventually there they are, and the drone will drop flotation device to them. If there had been sharks, they would have also dropped shark repellent. I don't know what that looks like, but there's shark repellent. So this is the first ever drone-based rescue. Pretty exciting. Now, we could, Baywatch style, send humans out there, but it's dangerous, right? Let's have the drones do it. Second example, we have a portfolio company called Zitline, and they have been delivering blood throughout Rwanda for a few years now. Altogether, they deliver 20% of all blood that's involved in transfusions in Rwanda, 25%. And they do it by a fixed-wing drone. So a doctor can order 4 liters of O-neg, and half an hour later, the drone will package up the blood, we'll put it on the drone, it will launch, fly itself to the destination, drop off the payload by parachute, and then fly home, ready for another mission. What was happening before this is rather dangerous driving, right? So if you're a driver trying to deliver the exact same blood, you've got weather, you've got terrain, you've potentially got rebel soldiers on the path. That's a dangerous job. Let's have the drone do it. Here's another example from a portfolio company called Shield.ai. It turns out the most dangerous operation we ask our soldiers to do, this has been true since 9/11, is an operation called clearing. It's kind of what it sounds like. Clearing is the task of running into a building that you've never seen before, rooting out the bad guys, and not shooting the good guys. So imagine how hard a task that is. And imagine if there was a drone that could do it. And that's exactly what Shield.ai has built. This drone is called the Nova. You carry it in your backpack until you find that building that you want to clear. And here's what it looks like. You drop it off at the front door. The drone will fly through that building, explore all of the passageways. It'll transmit the video and build a 3D map of that building as it flies. It will also start doing friend versus foe identification of the people inside. So if this is the most dangerous job that we ask our soldiers and civilians to do for us, let's get the soldiers out of those jobs and put the drones in. Now, some of the jobs I've just described are obviously dangerous. It's obviously dangerous to run into a building if you don't know who's in there. But not all jobs that are dangerous are obviously dangerous. In fact, the Bureau of Labor Statistics says that the most dangerous job in the United States is actually long-haul trucking. In other words, there are the most fatalities associated with this occupation than any other. And that actually understates the number because what the Bureau of Labor Statistics just counts is fatalities that are essentially truck wrecks, right? How many people got killed when they wrecked the truck? But the CDC has done a study of people who do long-haul trucking. These are the people who are away from home for weeks at a time because they're driving across the country. And they found that 69% of long-haul truckers are obese. Okay, so compare that to the normal population, which is that figure is a third, already too high, but truckers are at 70%. And then another 17% on top of that are morbidly obese. They are more obese. I think that means a body mass ratio of something greater than 35, right? Morbidly obese, a BMI. We have got to get the truckers out of the cabs because if you are this overweight, you are much more likely to get type 2 diabetes. You're much more likely to get cancer. You're much more likely to get a stroke. On top of this, the truckers, because it's a long, monotonous, stressful job, are much more likely to use alcohol and smoke. So this is a job that dramatically shortens the lifespan of people who do it. We have got to get the truckers out of the cabs. And that's exactly what a set of startups here and in China are doing. Now, regular driving is also extremely dangerous. The World Health Organization estimates that 1.2 million people are killed every year in road traffic accidents. It's the leading cause of death of young people aged 15 to 29, and they think it consumes 3% of world GDP, is recovering from fatal road accidents. So we've got to get human drivers out of the cars as soon as it's safe as well. We have a set of portfolio companies hard at work to do that. DeepMap is building beautiful, detailed 3D maps that the algorithms can use to safely drive. Applied Intuition makes a simulation system so that people building these systems can test and retest their algorithms to make sure they're behaving exactly as expected in all types of conditions. Voyage is operating a robotaxi service in retirement communities. And so as we lose our ability to drive, we don't need to lose our ability to connect with people, to visit our friends. And Syngin is working on a whole set of self-driving software that can work in a wide variety of vehicle types. So we've got to get drivers out of the cars as soon as they are safer than us, which apparently is a pretty low bar. All right, last city, and my favorite category, software that helps us understand each other. There's two Cambridge-based companies, one called Affectiva and one called Brainpower. What they've built is an application that helps kids with autism recognize the emotional state of people around them. One of the challenges autistic kids have is that sometimes they just don't see that somebody's getting angry or frustrated. And so if they could see the video of the person and then we superimpose their emotional state right over it, they can then modulate their own behavior. So the holy grail of natural language translation is basically any language pair, take any two languages, and do real-time translation, which is as the speaker is talking, you're getting the translation right in your ear, right? So that's the Star Trek Universal Communicator. What makes this hard? It turns out that human translators who do real-time translation are actually just a tiny fraction of all human translators. Very few people qualify for this work because it's so hard to do. It's such a hard mental task. And so in the United Nations, when people are doing that real-time translation thing, right, they got the headphones, the diplomats sitting there, they're listening to the speech and the real-time translation's coming in. What I found was that you can only do that work for like 20 minutes. And so if you have a speech going for an hour, there's actually teams of translators and they have to trade off because like after 20 minutes, your brain is mush. You can't do it anymore. It's too demanding. What makes it so demanding? So not only do you have to do the translation and understand the cultural nuance, and that's already hard. You already see that in Google Docs, right? In the translate feature in Google Docs. But you don't have the full document as context. You only have the real-time audio as it's going, right? You have like a sentence worth of context. So this is the holy grail of natural language translation, real-time, any language to any language. Let me show you a demo that Baidu put up on the web just 3 weeks ago to give you a sense of how far we've come. So you're going to hear an audio stream. The first thing you're going to see is what we call automated speech recognition. It turns that into a string of text. In that case, it's Chinese. And then seconds later, you're going to start seeing the English translation. Let's watch.
百度在18年前创业，赶上了互联网的浪潮。2000年，当时中国只有1000万互联网用户，今天中国的互联网用户已经超过8亿了。AI 对于社会的影响将远远超过互联网。过去的20年，我们都感受到了互联网所带来的变化。接下来的几十年，我们将体验到 AI 给社会所带来的更加深远的影响。
All right, so how this works is in order to keep up with the real-time speech, the system is actually generating predictions of how the sentence will end. Right, so it's kind of like Google autocomplete when you're in the search bar. It has the 17 often funny suggestions of how the search is going to end. So the system actually has to generate all of those probabilities and then translate those, because if it doesn't forward translate those probabilities, it's going to fall behind. And so this is a snapshot at a moment in time. Imagine this technology in every web conference, in every conference room that you go to. How much flatter would the world get if you can collaborate with people whose language you don't speak, because you're going to get it. A real-time translation of what they're saying. Awesome. All right, my last example. There's a nonprofit called the Crisis Text Line, and what it does is it counsels people in crisis. So where an older generation might have called for that help, right, phone conversation, this nonprofit serves the people who are more comfortable texting. When the center started, they asked all of the trained counselors to generate a list of 50 words that they think are trigger words. In other words, who is most likely to hurt themselves? And the words were kind of what you would expect. They are words like die, and cut, and suicide, and kill. Then we collected the corpus. We started looking at the interactions between people in crisis and their counselors. And we used machine learning techniques to figure out what is most likely to predict a suicide. And the results were very surprising. The word ibuprofen is 14 times more likely to predict suicide than the word suicide. The crying face emoticon is 11 times more likely to predict that somebody is truly in crisis, as opposed to any one of the words that the human people had guessed. So machine learning is helping us understand each other even in the depths of your most existential crisis. We want to unleash the algorithms to make us better decision makers on what words are going to trigger a suicide. The second study that the team did, and this was led by Yuri Leskovic, a professor at Stanford. He's here at the summit, so if you see him, ask him all about it. And they tried to look for what are the best practices of counselors. Once we know somebody's in crisis, what can we do to maximize the likelihood that our intervention will be successful? And he found a couple interesting things. I'll just share one. You can read the whole paper. One of them is that the most successful counselors get right to the core issue and begin working with the person on a solution, which is a little counterintuitive. You might expect that you want to develop rapport so that they trust you. The data shows the exact opposite. We want to get to the root cause as soon as we can and begin collaborating on solutions rather than establishing rapport. So here's machine learning that helps us understand who's truly in crisis, and then machine learning helping us figure how do we best help them. These systems will help us understand each other in a deeper and more profound way. So look, I'm very excited about the future of this technology, but we're not going to get this automatically. We're going to need to design these systems carefully. We're going to need to use compassion in the design process. And so, as I finish up here, I want to offer 3 thoughts about how we do this, how we maximize our chances of getting into this world where we're better together, machine learning and humans. So first is, we need to make sure that we design to benefit everyone. It's always been true with computer science that if you feed the system garbage, you will get garbage out. So I gave you an example earlier. If your organization systematically promotes men over women, if you train a machine learning system on that, you'll get the same thing out. You'll get a system that prefers men. So we need to make sure that we're feeding the right data into these systems so that it will generate the predictions that we actually want. And luckily, there are now systems from Google and Accenture and IBM that will actually do completeness checks on your data sets to flag potential problems that, like, look, you might be accentuating an existing bias that you have in you or your organization. So you want to make sure to counterbalance that. One of the hot new jobs in companies that are taking machine learning very seriously is the job at the bottom. This is a brand new job that didn't exist last year, and it's called the Director of AI Ethics and Policy. So it is a senior leadership position, reporting often to the Chief Innovation Officer, to the Chief Technology Officer, or sometimes to the CEO themselves. And their job is to make sure that all of the machine learning projects that are underway are inclusive and fair and generate the results that we actually want. Second, there's signs that this could turn into a nation-on-nation arms race. China certainly seems to be thinking that way. And let me just do a public plea that it doesn't have to be this way. And I want you to imagine what it was like in the age of computing and how much progress happened when we all ran proprietary code, which is basically true from the dawn of computing till, say, like the late 80s, early 90s, when open source started being a thing. And then think about how much progress we've made since open source was the way that we collaborated. We shared rather than hoarded. And I think we can do that with AI. We make more progress faster together if we share. Just think about how much progress we've made since Linux got open sourced, or think about the Android ecosystem, or think about GitHub as the repository for all of these open source things. Think about TensorFlow, which is Google's machine learning product. Let's keep on going that direction rather than having it be a zero-sum, my nation wins at the expense of your nation. And then finally, I want to talk about jobs. So in the early days, the first reports on what would happen with jobs in the era of AI were very pessimistic. You saw the McKinsey number up front, 30% of us would be unemployed by 2030, something like that. More recently, other analysts have been suggesting that we'll actually net create more jobs than we'll destroy. Certainly, we will destroy jobs. And just a reminder, a lot of those jobs we want to destroy. We have got to get the truck drivers, the long-haul truck drivers, out of their cabs. It's killing them. So those jobs we want to go away. So we need to be mindful of how we can create new jobs. And so what kind of new jobs will be created? I picked a 2x2 matrix by Kai-Fu Lee, an early AI pioneer. I think this is a good way of thinking about it. So the x-axis is how much creativity and out-of-the-box thinking will we need. Okay? So we're going to automate a lot of the routine things, and we're going to have a harder time automating the creative things. So obviously, creative jobs will continue to exist. But there's another axis that I've never before seen in one of these analyses, which I love, and it's this axis of compassion. Which jobs will need compassion for us to do them well? And as I mentioned, we don't have a real way to automate compassion. Machine learning doesn't know how to do that. And so there will be tons of jobs where they might be routine, but we need compassion to perform them well. So think about a teacher or a tour guide or a high school teacher or a elderly companion or a crisis hotline volunteer or a health coach. All of these jobs fundamentally depend on empathy and understanding each other. It's the infinite in faculties part that we can empathize with each other. So those are the jobs that we're going to create, and let's lean into it. And how do we do it? How do we prepare our education system for this world? Well, as I was thinking about this, I kind of remembered a book that was popular when I was growing up. It was written in the 1980s by this minister named Robert Fulghum, and its title is All I Really Need to Know I Learned in Kindergarten. And if you look inside these books, it's exactly these recommendations that I think we need to double down on inside our standard curriculum, heading into a machine learning dominated world. What we need to do is teach our kids to play fair, to not hit people, to share everything, to be aware of wonder, to say sorry when you hurt somebody. These are fundamental values of compassion and empathy and understanding and fair play and mercy. And these are the things that we don't know how to automate with machine learning today. So if we can take the awesome recommendations that machine learning can make and wrap them in the cloth of compassion, then we really will be better off together. Thank you.